Hello everyone. In this video, I'm going to provide a simple step-by-step tutorial on how to use the Gemini API with Vision. By the end of this video, you'll have everything you need to integrate AI Vision capabilities into a wide range of different applications. Gemini 1.5 is a multimodal model and allows us to add images and videos to our prompts along with text. There are plenty of ways that AI Vision can be used in applications. These include things like explaining complicated diagrams and charts, generating audio descriptions of images, and then using text-to-speech to improve accessibility for visually impaired people, creating stories or funny memes from pictures. And there are also specialized applications like disease detection from images in healthcare or monitoring agriculture and wildlife. The list really goes on and on. For this video, we're going to focus on 3 applications, which will include explaining complex diagrams, generating written descriptions from images, and also making memes from images. I'm going to start off by going to Google AI Studio, go to ai.google.dev, and up at the top, click Gemini API. Next, click Get API Key in Google AI Studio, and create an account if you don't have one already. We'll create an API key in a few minutes. First, go to the left sidebar, click Create New Prompt, and click Chat Prompt. This is the Gemini playground, and it's where you can experiment with different prompts and parameters before you start writing the code. The system instructions here are where you can instruct the model on how to act and respond, give it roles, tasks, goals, and specify output formats. The model parameters are in the right sidebar. Temperature is like a dial that allows you to control if the model will be more flexible and creative, which is closer to 1, or more deterministic and accurate, which is closer to 0. You can use the safety settings if you want to block or unblock certain types of content. And then down here in the advanced settings, you can specify the output to be in JSON and also enable code execution. Over here is where you would type in any text prompt. And as I said, Gemini 1.5 is multimodal. So in addition to text, you can also add other types of inputs to the prompt like video and images and audio. So let's test out a use case in the playground. For the system instruction, I'll use your task is to analyze images of complex diagrams and provide clear, accurate, and easily understandable explanations of what those diagrams mean. I have a diagram which I'm going to add just by clicking the plus icon, allowing Google Drive access, and then uploading my image to the drive, which will automatically add it to the prompt. So I have my diagram here, and then in the prompt, I'm just going to add the text. Provide a detailed and easily understandable description of this diagram. I'll click Run. And what it's telling me, this diagram illustrates the architecture of a transformer network, a powerful model used in natural language processing. It talks a little bit about the inputs, the input embedding, the outputs, the encoder-decoder stacks. So this looks pretty good, although it's a fairly complicated explanation. So since this is a chatbot, I can actually interact with it further. And I can just say, explain this so that it is understandable by a 12-year-old. And I'll submit. So imagine you're trying to translate English to Spanish, but you can only read one word at a time. You have a friend, the transformer, who's really good at this. Here's how your friend works. So it just explains in fairly simple text how the transformer architecture works. I can also ask specific questions about different parts of the diagram. But this is good for now. I'm fairly satisfied with this. The next thing we want to do is actually turn this into code. So to see what the code looks like based on what we've set up so far, we just go to the top right here and click Get Code. And here we have the option to view the code for JavaScript, Python, Android, and Swift. We're going to use Python. I'll just walk through this first. So the first thing we would have to do is import the Google Generative AI library. Then we'd have to load in the API key. After that, in order to use images in the prompt, we actually have to upload those images to Gemini. So there's this function here, upload to Gemini. It takes the path to the image and the image type as inputs. We can learn a little more about this by going to this link. Then if we scroll down further, we have this dictionary generation config. So this has all the parameters like the temperature, the max output tokens, and the format that the response will be in, which in this case right now is just plain text. Next, we create an instance of the model with genai.generative model. Here we add the specific model that we're using, which in this case is Gemini 1.5 Pro. We add the parameters with generation config. Here is where we can also add the safety settings, but we're not going to worry about that right now. And then as well, the system instruction that we created, which explains the task of analyzing images of complex diagrams and providing explanations. To make the files available to our local file system, we need to use this code. So files equals a list, and this list contains each file. So right now we just have one image. We use the upload to Gemini function. We would add the path to the image and then the file type. Then we start the chat session with model.startChat. History is a list that contains all of the exchanges between the user and the model. So any of the inputs that we provided the model and any of the model's responses. And then finally, we can send our message to the model with chat session.sendMessage and then print out the response. So I'm going to copy this code. I'm going to go to my VS Code terminal. I created a folder called Gemini AI Vision that we can work in. And then I'm going to create a file, and I'll just call this vision.py, and I'll paste the code in here. There are a few libraries that I'm also going to have to install. These include Google Generative AI, which is how we're going to access Gemini, and as well Python.env, which is just going to be used for handling the API key through an environmental variable. I'm going to open up a terminal. And then before I install these libraries, I'm just going to create a virtual environment and activate it. Now I can pip install my libraries, Google Generative AI and Python.env. And now that that's complete, I can go back to my code in vision.py. So I'm just going to clean this up a little bit. So we're importing our OS, we're importing our Google.generative AI as Gen AI. Now we have to load the API key. I'm going to go back to Google AI Studio. Over in the left sidebar here, I'll click Get API Key. And then I'll click Create API Key. Now that this is done, I can copy the key. I'll go back to my VS Code and I'll create a .env file. This is where I'm going to store my API key. I'll call it Gemini API key, and I'll just paste it in and save. To load the API key as an environmental variable, I'm going to use python.env from .env import load.env and then the function load.env. Now I'll just make a slight change here. API key equals os.getEnv, and then I'll put this in brackets. Great, now we should have our API key loaded and ready to go. I'll take a look at the upload to Gemini function, and everything looks good here, no changes. I'll look through the parameters in generation config, everything looks good there. Here again, we create the model with genai.generative model. All of these parameters look good. I'm just going to clean this up a little bit. We're using the Gemini 1.5 Pro. And now we have to set up the files using the upload to Gemini function. So I'm going to get a new diagram. And this is the diagram here. It's from a chemistry research report. So we will replace the file name here with chemistry diagram. File type is correct. It's a PNG. And then in this next section of code is where we start the chat session. So I'm going to clean this up a little bit. We don't need all of this section of the conversation. And so the way that this works is we start the chat session with model.startChat, and it takes one input, and that's history. So history is basically a record of the conversation, which means every time that we send a message to the model, we need to add it here. And every time we get a response from the model, we also need to add it here so that it understands the history of the conversation. And it's important to provide Gemini with the data exactly the way that it's expecting it. But the way this is structured is that each message to or from the model is a dictionary inside of this list. And then each of those dictionaries has two keys. One is role, which can either be user if it's a message from us, or model if it's a response from the model. And the other key is parts, and this is what includes the information that we're either sending or receiving to the model. Parts is a list, and the list will include the text and then also any files we send along. So we can see here we're accessing the files list, which has our diagram by just saying files and indexing 0. So we could add more files to this list, and then we can access those files by indexing it. We only have one file, so we're indexing that file with 0. And then here we're providing our initial text input or message to the model, which is provided detailed and easily understandable description of this diagram. So I'm actually going to take this out for now, and we're going to initialize this chat session with 0 history. Then we're going to create a variable called initial response. And that's going to equal chat session.send message. And that message is going to be that dictionary, which includes our role being the user, and then the parts of our message, which includes the file, the diagram, and then our initial text prompt. So I'm going to put this in here. So we'll be sending it to the model. We're going to print the initial response. And the way we're going to get the text is just the initial response object.text. And then we're going to append my initial message and the model's response to the history. And we can do this just with chat session.history.append initial message, and then chat session.history.append initial response. So we can test this out, save it, and see how this works. Python vision.py. Great. So I notice it does take a little while to load the image, but so here is the response. The diagram illustrates a 2-step chemical reaction sequence. Step 1, step 2, and then it explains this in pretty good detail. So that looks pretty good. I'd probably want somebody who's better versed in chemistry to review it, but for the most part, that looks pretty good. But I want to, of course, be able to go back and forth. So this is the initial response that we're getting from the chatbot, but I also want to be able to ask it follow-up questions. And what we're going to do to achieve a back and forth conversation is just create a while loop. And then once we get this response, we can create another variable called user message, which is an input. And then we have to create this data structure here so that we can send it as a message to the model. I'll call this user message object equals a dictionary. The first key is role, which is user. And then the second key is parts, which is a list. And in this case, that list just contains the text message that I'm sending to the model. Now we could add in more images, but that's not necessary for this purpose. And then we will create the model response equals chat session.send message. And this will be the user message object. We can print out the response with model response text, and then we will add our message to the history with chat session.history.append user message object, and then add the model's response to the history as well. Chat session.history.append, and then model. I'll save this, and then we can test it out in the terminal again. Okay, so it's giving us the explanation, and I'm just going to provide a follow-up. So can you explain this so that a 12-year-old understand? I am getting an error here, and I think I know why. And I think that's because I'm not adding the model's response correctly to the history. So instead of adding the whole initial response, I'm going to just put this in the correct structure, create a dictionary, first key role, and that's going to be model. And then the second key is parts, which is a list and contains the initial response dot text. And then I'm going to do the exact same thing down here. Create a dictionary with role, model, and parts, model response dot text. So this should hopefully work. I'll save it and run it again in the terminal. Great, so it provides the explanation, and then I'll just ask my follow-up question. Please explain this so that it is understandable by a 12-year-old. Great, so it provides another explanation here. So it's saying, now you have two cool shiny pieces, one blue, one purple. Each shiny piece has 5 smaller pieces stuck to it, like a hand with 5 fingers, and then it goes through the steps. So this is a more basic explanation, and I can continue, of course, going back and forth with it, but this is good for now. And you know, you can really see the potential with being able to use the Vision AI in order to get information out of images. And this might be summarizing complicated documents or things like research reports or web scraping and being able to add the information from images. So in the past, if you were doing a summarization or a web scrape, you're really only getting the textual information, and then any of the information in the images would just be lost. Whereas with Vision, you can actually get all of the information, including images, which the implications of that are really wide ranging. So this is extremely impressive. Okay, so the next use case that we're going to work on here is for the model to describe images which might be on a web page, and those descriptions would be added to a text-to-speech model to improve accessibility for visually impaired people. I'm going to create another file called accessibility.py. And most of the work has actually been done in the vision.py file. So I'm just going to copy and paste this into accessibility.py. And the only things that we really have to change here are the system instruction, and then of course the file that we're using, the image we're using. So I've created an image here called testimage.png, and this is just a person speaking to a robot in a room with a stock chart in the background. Going back to the accessibility.py, the first thing I'm going to do is change the system instruction. And I'm going to change this to your task is to analyze and provide a detailed text description of the following image. Your description will be used to improve accessibility for visually impaired people. The description should include any people or objects in the image, the background, any actions, and the overall meaning of the scene depicted in the image. Now I will change the image file here to testimage.png. I'm going to save this. Then I'm going to clear the terminal, and I can test this with Python accessibility.py. Okay, so what does it say? It says that the image shows a futuristic scene of collaboration between a robot and a man in a data center. The robot is metallic silver with exposed wires, blue eyes. To the right, the young man in a sharp business suit sits attentively facing the robot. In the background, it is filled with rows of server racks. The overall atmosphere is high-tech and futuristic. It also mentions likely financial sector because of the stock chart in the background, phase a sense of progress. So this looks pretty good. One thing I could do is I could say, could you summarize the description into a single short, and its responses: in a futuristic data center, a silver robot and a young businessman collaborate on analyzing financial data displayed on a transparent screen. So this is really good. And obviously what we would do with this text description is that we would add that to a text-to-speech model. So it would provide the audio. And I actually did recently a video on text-to-speech with OpenAI to show how easily that could be implemented. So I'll include a link in the description for anybody that's interested in that. But we can see again here, this has very useful application for anybody who is visually impaired, or just for anybody who wants to get an audio transcription of a page, including the images as well. Great. So we have one more use case, and that is to create a meme generator with images. Okay, so once again, all we need to do here is copy this code. I'm going to create a new file called meme.py, paste the code. And the image that I have here, memeimage.jpg, is just this image that I got online. So we'll see what type of witty text the model can come up with to create a meme out of this. Let's go back to meme.py, and the only thing we need to change, well, one of the things I'm actually going to change here is the temperature, because I've mentioned before that temperature is like a dial whereby you can control whether or not your model is creative and flexible, which would be closer to 1, or more deterministic, predictable, and accurate, which would be closer to 0. Right now it's at 0. I'm going to crank this all the way up to 1 because this is a creative task. In the system instruction here, I'm going to replace this. And the new system instruction is just going to say your task is to analyze the provided image and generate text to combine with the image to create a meme. The text should be funny, clever, and insightful and fit well with the image. Keep the text relatively short and punchy. Provide 5 possible text options for this image. We also need to change the file name. This is meme-image.jpg. And then we also have to change the file type from PNG to JPEG. And then the other thing I'm going to change here is just the text that we're providing in the prompt. So I'm actually going to take this out, and I'm going to say generate 5 text options to combine with this image to create a meme. Okay, everything else should be good. I'll save this. I'm going to clear the terminal, and then I'll run the file python meme.py. Okay, interesting. It's saying that we're getting an error. It's saying unsupported type image JPEG. So one of the things I can do here is just go back to Google AI Studio, create new prompt, go back to the prompt window, and I'm just going to load that file into the playground. And then I can go up to get code, and I can see what type of value it's expecting. So it's actually still saying image PNG, which is interesting. So I will try that out. I'm going to save this, and then I'll rerun the code. Okay, so this worked. Let's see what we have here. So the text number 1 option here is me trying to explain why this time it's different. Okay. Option 2 is bought the dip, now I'm the dip. Okay, it's not too bad. Option 3, my retirement plan is fueled by sheer optimism and this one weird trick. Option number 4 is when your entire portfolio is one meme stock. Yeah, I guess. And then option number 5, sure the market's down, but I'm up 0.02% on a random Tuesday. So a couple of these are not too bad. but we can continue to fine tune this and prompt it better. We can get better responses, but I still think that for the amount of effort that I put into the prompting, the system instruction, a couple of these are fairly decent as far as memes go. There could definitely be some improvement. I know I said we were going to do just 3 options, but I decided we're going to try one more use case as well. And this is using multiple images in the prompt. So I have 2 images here. These happen to be of watches. One is an expensive watch. This one is worth about $3,000, image 1. And this one is worth less than $100. I'm going to create a new file called image compare.py. I'll paste in my code. And this time I'm not going to use any system instruction because the system instruction is optional. So I'm just going to take that out. That's going to be an empty string. We're going to actually load both files to Gemini. So the way to do this is I can just copy and paste this line of code here, upload to Gemini, and then I'll replace the file names with image 1, image 2. And now scrolling down to the initial message, I'm just going to add files and index 1, comma. And then for the prompt, I'm just going to say, review the products in these 2 images, estimate the cost of each product, and tell me which one is more expensive. Now, the answer I want is image 1. So that looks good. I can save. I'll clear the terminal, and then I will run this file, Python image compare.py. Okay, and I do get an error here. And that comes from the system instruction. So I actually can't leave that as an empty string. I believe it was optional. What if I just remove this entirely? Save and run the file. Okay, so there's another image here, file not found, image1.jpg, of course. So these are PNG files. Save it again and run this again. And here we go. The Long-Eins watch on the left is significantly more expensive. Long-Eins watches are a luxury Swiss timepiece, and this model likely costs several thousands of dollars. Fossil watches, while stylish, are considered a more affordable fashion brand. The Fossil on the right likely costs between $100 and $300, and that's absolutely correct. It's this watch here that is the more expensive one, and then the Fossil watch is about $100. So that works. So just looking at this code again, all we did to add multiple images is in the files here, we just added 2 uploads to Gemini. We uploaded each image. And then in the message, in parts, we just added both of those images from the files. So indexing image 0 and indexing image 1, and then our text prompt. And we're able to work with that. So you can compare images, you can describe images, you can generate text for images. So great. So there's really a lot that we can do with this vision technology, adding vision capabilities to applications. We're really just scratching the surface here, but the possibilities are almost endless. Now, I'd really be interested in hearing about some of the ideas that all of you have. If you want to post something in the comments, an idea of how vision can be applied to an application or a new application that can be developed using vision capabilities. I'm certainly interested in exploring this topic further, but this is good for now. If you enjoyed this content, please consider hitting the like button. Please consider subscribing. If you have any questions, post them in the comments. I'm happy to answer them. I'll be coming out with many more videos on similar topics. Thank you again for watching, and I'll see you in the next video.